Okay. So, we were just talking the last couple lessons, right? This last lesson and the one the other day. We were talking about measures of variability. We were talking, we talked about surveying, right? Surveying people using samples instead of a whole population to get results. Obviously, that's what statistics are all about. So what we want to do is we want to take those, for example, measures of variability, measures of center, being able to crunch the data, and then after we crunch it, right? Meaning that's just a casual way of saying to calculate it and analyze it and pull conclusions off of it. We want to be able to compare them. All right. So, let's say one of the problems we did last lesson was on the price of books, right? And let's say that in this case we found out our mean absolute deviation off of that, our mean and our mean absolute deviation. Well, what if that was only one bookstore and then another bookstore had the same thing? So that's kind of what we're talking about. We're going to do it with both populations, I guess you would say, on two different examples and then compare them. All right? So that's what this whole lesson's about. So it's just a little extra based off of what we've already learned. So here we go. When it comes to this, though, we're not going to be looking at charts or tables. A majority of these are going to be graphs. All right, so let me share with you guys what kind of graphs we're going to be seeing. Okay, the first one we're going to talk about is a box plot. Everyone? Box plot. All right, so here's what the book describes a box plot as: a diagram that divides a set of data into 4 parts using median and quartile. So this should sound familiar, right? A box is drawn around the quartile values, and whiskers extend from each quartile to the extreme data points. All right, so with all that said, in your little box, just draw that. And that's, if you want to put points on each major part, feel free. That is a box and whisker. Now, if that's a box plot, our next one is a double box plot. Everyone?
Double box plot.
And this is 2 box plots graphed on the same number line. So you're going to see a number line where these boxes are going to be, right? The box and whisker is going to be above it, but there's going to be one stacked on the other above the same number line for us to compare the data. And right there it just says, it's not so much a definition, but a little reminder that this is actually better for comparing, since they're right next to each other. All right, so grab your book. Piece of paper, here we go. Name, date, period up at the top. Make sure our name is written large enough. Okay. All right, so we talked a lot in our vocab, right, about box plots, but what we're going to do is we're actually, our very first problem on page 457, you can take a look at problem number 1. That's actually not a box plot. We will get the box plots in just a bit, okay? But because our last lesson was on mean absolute deviation, I want to talk a little bit about a dot plot, all right? So, I'm going to try to use our book where you guys can see, since I can reference it a little bit better. All right. All right, so number 1, okay, it says, let's close read this. It says, The double dot plot below shows the scores out of 20 points for 2 different class periods. Compare the and variations of the 2
populations.
round to the nearest tenth. Write in. You can draw about the 2 populations. Okay. So first off, all right. I don't know. I can't remember. Have we looked at dot plots yet this year? In another lesson? Okay, so it's quite easy, all right? I just want to make sure, though, that this first time around that I kind of translate it for you, and here's what it is. Now, first of all, this is a double dot plot, right? There's one on top of the other. The number line down here refers to both. That's why this one doesn't have numbers, okay? So here's your second period class and your 5th period class, all right? And the results. What this means is for example, this one right here for second period that has 3, okay, that means that 3 students scored 15 out of 20. So each of those is a data point, or in this case, a person, a student, okay? For 5th period, for example, this 1 right here above the 20, that means 1 person scored a perfect 20 out of 20, 100%, all right? So that's kind of how we're going to read this. So just realize that they're stacked on each other for a reason, okay? Because we're using just this bottom number line here, and it helps us compare just by visually looking at it. All right. So with that said, okay, I'll use a red pen for this. Okay, so we have step 1. Okay, on here it says compare the centers. Now listen. Okay, they're talking about the measure of centers. All right, measures of centers. So the centers, measures of center is here's what they would like you to do. For a dot plot, they're actually talking about the mean. Now, in just a little while, you're going to see a box plot, and we'll come back to this, a double box plot. They're going to be talking, like we did the other day, about the median. Okay? But for this particular problem, it's the mean. So, that's what we're going to do. Step 1, we're going to find the mean of each period. All right? So, you might want to do that, put a little times 2 here. All right? So, here we go. Finding the mean of second period, I'm going to go ahead and I'm going to do it vertically. So here we go. That number right there is 14. This number right here, there's 3 15. So 15, 15, 15. There's 4 16. So 16, 16, 16, and 16. There are 3 17, so 17, 17, 17, and there's 1 18. Now what I probably want to do, by the way, is make a little note to myself where I don't lose track here. This is for my second period class when it comes to their quiz scores. So, finding the mean, right? I'm going to go ahead and say 14. Now, to speed this up a little bit, some of these I can combine in my head. So I'm not hitting plus 15, plus 15, plus 15. I can say 14 plus 45, all right? And then plus 16 plus 16, well, that's 32. Plus another 2 16s, which is 32. Then 2 17s I know is 34. Plus, and then 17 plus 18. Or you could have said 35, which is 192. Of course, finding the mean, right? 192. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these. So 192 divided by 12, and I get 16. Okay, that's our mean. Now, step 2 is, they say, the variations. Okay, so Variations, here's what they're talking about. They are talking about the mean absolute deviation, or if it's the box plot, double box plot, they're talking about interquartile range. Now, obviously, if you're dealing with a dot plot and you're dealing with mean, they're looking for, of course, what's related is mean absolute deviation. Median expressed, of course, with the median, then you have your first quartile, third quartile, and so forth. That's the interquartile range. So on this particular problem, we're dealing with the mean absolute deviation. Okay, and I made a mistake. I should have left myself a little bit more room here. I told myself I would, and I forgot. All right, so here we go. Remember how we just did this. All right, so I'm going to go ahead and find the distance between our mean and each data point. So 14 minus 16, remember, we're just finding the distance. So absolute value of negative 2 is 2. Same thing here, 15 minus 16, just 1. Another 1. Another 1. 0. 0. 0. 0. 1, 1, 1, and 2. All right, so here we go. Add these up. Right, we can add this up just like this. 2, 3, 4, 5, 6, 7, 8, 10. I'm going to go ahead, divide 10 by the same 12. So 10 divided by 12 equals, I end up with 0.83 repeating decimal. It does say round to the nearest tenth. So tenth is right here, right? So it's 8/10. Okay, now the reason why we don't have very many problems on tonight's homework isn't necessarily because, I mean, it did take it took a long time, okay, but it's not that it's really that hard, right? It's just review from the last one, but it's the writing that's involved, okay? They want us to actually do some writing, so we're gonna have small little paragraphs to go with each problem, all right? So it says compare the centers and variation of the two populations. So let's go ahead and we're going to do step 3 and we're going to write this out. So we could say sorry. I already lost track of where I was, which I warned you guys about, right? I saw this and it reminded me. That's why I wrote it down. Okay, we need to do this twice. So I didn't want to do mean here and then mean again and then go back and do it since I already had all this written down and organized, right? Ladies and gentlemen, this is for period 2, right? Second period. That's why I wrote that. Okay, we have to do it again for 5th period's results. Okay, so I'm going to go ahead and do the same thing for 5th period. I'll go ahead and record it right over here. Period 5. So 14, 2 15s, 2 16s, 3 17s, 2 18s, 2 19s, and a 20. I guess I could have put step 3 repeat with our other population if you want to name it as a step. So here we go. I'm going to find the mean and the mean absolute deviation. So 14 plus 30 plus 32 plus 34 plus an extra 17 plus 36, okay, plus 38 plus 20 gives me 221. I'm now going to take 221 and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Divide by 13, and I get 17. All right, mean absolute deviation. Subtract 17 is 3, subtract 17 is 2, 2, 1, 1, 0, 0, 0, 1, 1, 2, 2, oops, and 3. So if I add this up, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 15, 18. Divide the 18 by 13. And the average distance is 1.3846, but if I'm going to round to the nearest tenth, it ends up being 1.4, almost 1.5 away. All right, now step 3. Woo! Oh, step 4. Sorry, it was what I was going to make step 3. Step 4. Now comes our writing. Now we can compare since we have both sets of data. All right, so here we go. I'm going to go ahead. I'll start with second period and state what I have. Second period. Our second period's data has a mean of 16 points. Since we're writing in sentences, make sure you have your correct units there. Has a mean of 16 points and a mean absolute deviation of, and I'm going to use the word about because I rounded it, about 0.8 of a point. Second period's data has a mean of 16 points and a mean absolute deviation of about 0.8 of a point. Then I'm going to put, then let's go to the other one. Fifth period's data has a mean of 17 points and a mean absolute deviation of, and we rounded that one too, of about 1 4/10 of, or I should say, because it's not less, just 1 4/10 points. So if it does say something about, and in this one, right, it says write an inference you could draw about the two populations, you're just stating, like comparing the numbers. So if I was to do this in terms of, you could almost say this is kind of step 5. It's kind of all part of step 4. Okay, besides stating all of our information in words, drawing an inference, you could say, fifth period or fifth period scores are, you don't want to say are larger, because they're not, right? Some people had higher scores even here, like in second period, someone had an 18, when in this period someone had a 14. So to be more specific, you could say fifth period scores are centered, right? Talking about measures of center, are centered around a greater value and then you could go on to say, we have talked about the mean absolute deviation, right? So the mean absolute deviation, remember, says how far is it away from the mean. So, or the average distance away from the mean. So meaning that the larger the number, the more spread out the data is. If you take a look. Second period has an 8/10 versus a 1 4/10. We'll take a look. You could even see visually how this is higher but more condensed when fifth period is more spread out. Okay, so if you're saying something like that, it says the fifth period scores are centered around a greater value. However, you could say fifth period's variation is greater. Therefore, the scores were more spread out. All right? I mean, it's a lot of writing, guys, for just pretty much putting what we just found mathematically just in sentences, right? Second period's data has a mean of 16 points and a mean absolute deviation of about 8/10 of a point. Fifth period's data has a mean of 17 points and a mean absolute deviation of 1 4/10 points. Fifth period scores are centered around a greater value, right? 17 compared to 16. However, the mean absolute deviation, or the variation, is greater. Therefore, the scores are more spread out, wider. Okay. Questions on that? I'm going to have you try one.
Instead of the mean absolute deviation, could we just put that from 18 to 16?
All right. All right, here's the one I want you guys to try. All right, problem number 4. Number 4. Okay, go. Number 4. I'll leave that up there for you. All right, I'll give you guys 30 seconds. Go. I'm joking, but you do need to get started. Go.
30 seconds.
Get started, guys. We're going to do Boxplot. Okay, checking in. How many of you need more time? Okay. Okay. How many of you still need some more time? All right. Okay, checking in. How many of you still need some more time? Okay. All right. I'm going to give you guys about 1 more minute, and then I'll have you guys share. You can bounce each other's ideas off each other. Okay, so there's a lot involved here. So what I, of course, want you to do with your neighbor is share your mean and your mean absolute deviation of course, both of the populations in your data. Okay, so make sure that those fit. And then, of course, at the very last part is read each other's paragraph or read your paragraph to the other person, especially the inferences or the conclusion that's involved, and see if you guys agree or disagree with each other on that. Okay, so because of all that stuff to share, I'm going to give you guys a full minute to share with your neighbor. All right, go.
For the mean absolute deviation for the girl, about 8 and for the mean absolute deviation for the
I got 65, and for the mean absolute deviation, I got 0.8, and for the girls, I got 69.
I put girls have a mean of 69 inches and 65 inches, and then add 0.8 inches. Boys did have a mean of 69 inches and add 1.2 inches.
I put the girls' data has a mean of 65 inches, and the mean absolute deviation of about 4.8. The boys' data has a mean of 69 inches, and the mean absolute deviation of about 4.8.
Okay, trying to figure out a way to get all this under the dot cam here for you guys. I don't think I'm going to be able to pull it off. Maybe I'll just do this sort of thing again. All right, here we go. So on number 4, right, it said the double dot plot below shows the heights in inches for the girls and boys in Franklin's math class. Compare the centers and variations of the two populations, round to the nearest tenth. Write an inference you can draw about the two populations. So here we go. Very first thing, I'm going to go ahead and focus in on the girls. And considering it's a dot plot, I'm going to find out, of course, the mean and the mean absolute deviation. So here we go. The girls, I have 63. There are 3 64s. 1, 2, 3. There are 4 65s. 1, 2, 3, 4, 5. There are 3 66s. 1, 2, 3. And 167. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And dots 1, 2, 3, 4, 8, 11, 12. Okay. All right, so here we go. I'm going to find the mean. 63 plus 128 plus 64 plus, I'll just say 65 plus 65 plus 65 plus 65 plus 66 plus 66 plus 66 plus 67. 780. And I said there were how many? 12? 2, 4, yep, 12. So 780 divided by 12 gives me 65. So there's our mean. Now, considering that's our mean, I'm going to go ahead and subtract 65 from each of these. So 2, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 2. And now find the mean of this one. So here we go. 2, 3, 4, 5, 6, 7, 8, and 2 is 10. So 10 divided by 12 is same as earlier, 0.8333. So remember when we rounded to the nearest tenth, we end up with 8/10. All right, woohoo! Girls are done. All right, here we go, boys. So boys, 66, 267s, 268s, 369s, 270s, 271s, and a 72. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Put my little 13 down here. All right, here we go. I want to make sure I'm careful. 66 plus 67 plus 67 plus 68 plus 68 plus 69 plus 69 plus 69 plus 140 plus 142 plus 72 equals 897. And divide that by the 13. $69. Here we go. No huffing and puffing. We're having a good time. 67. Two. This tests you on your focus. All right, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 18. 18 divided by 13. Equals 1.38. If I round to the nearest tenth, it becomes 1 4/10. All right, here we go. Actually, you know what? Let's save a little bit of time. All right, and you could say, of course, the mean for the girls, the heights of the girls in Franklin's class was 65, with the mean absolute deviation being 8/10. The mean for the boys' height would be 69 inches, with 1 4/10 mean absolute deviation in inches. And then you could say that, it depends how you look at it. You could say the girls have a lower center in 65 inches, and they also, you can say, are spread out less, okay, or grouped together more, okay. So explanations. Okay, I'm going to extend part 2 after this, all right, on a different video.